Okay, let me share my screen also. So as you know, this is a Solve with Us session. We will be doing this session on joinpd.com. So I request everyone open a new tab and go to this site joinpd.com and type this code FSM UBD. Yeah, in regards of quiz 2, so we have done some small analysis between the students who are joining the sessions and students who are not joining the sessions. And surprisingly, we got some 13 marks, average marks of 13. There is a difference of 13 marks between the two sets. So people who are attending sessions has the average equal to some 50, and those who haven't attended any of the sessions, their average is somewhere near 37.
Oh. So which sessions particularly? All the sessions or the
No, revision mock
mock?
these sessions.
Okay.
So we took two revision sessions, three revision sessions along with the TS session and the mock discussion session. So we took the data of these four sessions particularly, and I hope they are the people who will be joining the other sessions also. So I have seen the same crowd attending the normal usual sessions also. So that's the difference, and yeah. So
So when is week
people
9
are,
and 10 revision?
it's on 21st April.
Okay.
Okay, it's already scheduled. Okay, just open the calendar and check. Okay, the code. I will just type the code in the chat box also. FSM. It is visible on the screen. FSM UBD. So people who have gone through week 12, you might have understood that in week 12 there is nothing new, but the only tests, so we will be learning few more different kinds of tests other than G test. So there is T test and there is F test. So T test, chi-square test. So T test we use when we don't know the population variance. So if you know the population variance, we will use Z test. So the same Z test we can't use if we don't know the population variance. So we will compute the sample variance, and in place of population variance, we will be using sample variance. And while you use that sample variance, there will be some change. So it will not represent the population variance. So that is why the test will also change. It will no longer be a Z test. You can't use standard normal. So that is why we are going to use T table, student distribution. We call it as student distribution. And we perform the test and we conclude. By looking at the results, we conclude whether to accept the null or to reject the null. So in week 11 and 12, you are going to do only one thing. So you will strive to do only one thing. So given the information to you, you compute something and finally you compare two things and conclude. So you will only do the conclusion thing. The conclusion will be either you reject the null hypothesis or you accept the null hypothesis. So there are different cases in which you can actually reject null hypothesis. So one case is, so the problems will be like this only. Either we will give you, the setup will be like, we will give you some sample and we will give you the test statistic T, and we will give you the test also. So when to reject, and we will ask you to find.
Regarding the test statistic, I have a query from graded 11 answers. One of the questions, actually, we were considering proportion. Shall I give you question number, or you generally know the questions, right?
Yeah.
given proportion, so many out of so many, or so and so, like that. In that question, when it was asked what is the test statistic, when we give it as P, it was marked as wrong. They actually are saying sample mean is always the test statistic. But in that question, we never find any information related to sample mean at all.
Yeah, I also posted this question in the discourse.
I have gone through and I asked my TS to resolve the or answer that particular question. Okay, I see this question we got it from previous terms also. So we said.
Okay, sir, and in the same context, one more query is related to the critical value in the same question. Actually, I have posted this in the discourse. Critical value, when they are saying if more than 36 out of 100 are suffering from disease, you should reject the hypothesis, something like that. When we are considering proportion and we are writing in terms of P and the variance as P into 1 minus P by N and so on, then we should be taking critical values also as 0.36. Obviously, when we are doing is P greater than C, like that. So we should be doing P greater than 0.36 if it is given 36 out of 100 people are suffering. So that time critical value, as per general intuition, it turns out to be 0.36. But in the earlier this solve with the session also, it was explained like 36 only, and with the same thought we give in graded also, it is 36. Of course, it's right, but as per this logic, it doesn't sound convincing.
Okay, sometimes what happens, this proportion and the sample mean, so both will look alike. See, you see, when I say proportion, so multiply it by 100, multiply it by 100, you will see the sum or just the numbers. Sometimes it happens, but yeah, this doubt we got it in the previous term also. So let me check on this again. Okay, so at that time also we were convinced that we should award marks for those who have given proportion also. So we'll look into this. Okay.
Okay, sir. Thank you.
Sir, if I get the graded average assignments as 94, okay. Will I get 10 marks?
10 only. Yeah, 10 only.
10 only. Okay, thank you.
Sir, and this extra activity score that is pushed into dashboard, it has got some problem. In Discord, there are so many posts, but it is not rectified at all. It's been a long time.
No. We are internally verifying.
Okay.
So we have
I'm asking this only 4 weeks. I mean, up to week 4 only the marks are pushed. So in that itself, we observed this one or two problems, and we are not at revealed what activity marks we are assigned for the other weeks, right? So that's why I'm asking.
No.
Maybe in 12 more days they'll close all the process, right? So after the final and all. So that's why.
Sir, how many extra activity will be considered? All or their best?
All. There is no
best. No best.
No. See, this is an extra activity.
And for the assignment, it is best, right? Or all?
It is best. Best is 7 out of 10. Or no. Best is 7 out of 12. No?
No,
so I don't know.
It is 10 out of 12, sir.
Best is 10 out of 12. Okay.
10 out of 12. Okay.
Sir, in extra activity 5, I not got third review. So as you do not have enough reviews, your staff will grade your assignment.
Yes.
But I not got.
It will. You will get. Which extra activity you are talking about?
Week extra activity 5, week 6.
5, right? Okay. Wait. Till 3 we have completed. 4, 5 we will do.
Okay.
So it will take some time.
Okay.
Okay. Okay, let's do week 12 first. Then we will go back to week 11, and then we can talk about other things. Okay. So coming back in week 12, we will be doing a different tests which are called t-test, chi-square test, and f-test. So all these tests are used in different scenarios. So as I was discussing, t-test is basically used in place of z-test when the population variance is not known. So we can only use that z-test which you have learned in week 11 only if you know the population variance. So in your problems you might have seen the population variance will be given to you. Assume the standard deviation or the variance is this. But if it is not given and the other situation is same as it is, except this you don't know the population variance, what we will do is we will compute the sample variance in place of that population variance, and we will be using the sample variance to compute the probabilities or alphas or betas, these error probabilities. Okay, so other things will be same to same, but as we are using sample variance instead of population variance, we will not be able to get the same graph like normal. Rather, we will get a t distribution. So yeah, t distribution will have some degrees of freedom to attach to it because we are using the sample variance. So depending upon the number of variables you took in your sample or number of data points you have taken in your sample, it will affect the sample variance. So taking only five instances and computing the sample variance, taking some 100 or 200 samples and computing the sample variance for that 100 samples, that there will be a difference between these two, and this sample variance of the 100 samples you have chosen will be much more better estimate for population variance than this 5 samples. Okay, so that is why the number of samples plays a role in this distribution, and that number of samples, out of those number of samples, when you compute the sample variance, you require the sample mean. So your sample mean is fixed. So once you fix your sample mean, then the number of samples that can freely vary is n minus 1. So that is why there will be n minus 1 degrees of freedom. So this degrees of freedom is not a big thing. Degrees of freedom is, treat it like this: how many variables can freely take values in your while you are estimating. So in sample variance, you from x1 to xn minus 1 can vary, but xn cannot vary because you are fixing your sample mean. So once you fix your sample mean, now that xn is a function of this x1 to xn minus 1. So okay, that is another, that is out of our subject. Okay, so it's like for t distribution there will be a role of number of samples you take, and that role is nothing but the number of degrees of freedom. As this degrees of freedom gets increased or tends to infinite, then what happens? So your t distribution will slowly converge to normal distribution. Think about this. When this n becomes large and large and this tends to infinite, so that means you are computing the sample variance by taking n infinite. So that means you are taking the whole distribution and computing the variance, which is nothing but equal to population variance. So once it turns out to be the population variance, it is very equal to z test. Okay, I'm saying all these things in words. Okay, I'm not writing anything. Hope you people understand this. So after t distribution, see this t distribution and z distribution, we will be using this two tests to verify or test the sample mean. So we have only two tests. One is z test, which you have learned in week 11, and another one is t test, where we test for sample mean. And then we will test for sample variance, and for testing variance, we will use chi-square test. So all these tests, see when I say z test, we will be using standard normal, so z table. When I say t-test, we are using t-test, so that means you have to use t-distribution. So when I say chi-square test, that means we have to use chi-square distribution is involved in this particular test. So like this, when I have to compare two sample variances, then I will be using F distribution. Okay, that is called F test. So if I am using F distribution, then that test is called F test. Okay, so let's get into problem. I will do the first problem for you. So I'll give time and we will discuss the first problem very much in detail. And from second problem, I'll give more time and let you solve the problem. Okay.
So when you said when the n increases, the t-test tends towards z-test.
The t distribution will slowly converge to z
normal.
distribution. Yeah.
Okay. So in this case, what should be? I mean, what number we should be looking at? Like n. I read somewhere if it is more than 30, it is like that.
See, usually what happens is if n is more than 30, there itself it is very much converged to normal by using the CLT or whatever. See, it will converge. Okay, when n is very small, like 10 or 8, or maybe even less, 5, 6. So then the sample variance may not represent the population variance correctly.
Right. Okay.
Okay. So for that we cannot convert our test into z test, or standard normalization cannot be done that easily when we are using sample variance. Okay. So that is why we have come up with a student distribution. We call this as a t distribution.
Right.
So yeah. So this is built by students. Like we built it. So we have computed these things, and we have designed this table. Okay. For each and every n.
Okay. Yeah. Thank you.
Yeah. So let us start with very first problem. So I will just skip this. Even I hope this will work fine. So let us start with this particular problem now. So in the past, the standard deviation of weights of salt packages filled by a machine was 40 in grams, so 40 grams. To decrease the standard deviation of weights, a new machine is introduced. So now a random sample of 25 packages from the new machine showed a standard deviation of 32. Based on this data, what is your conclusion at a significance level of 0.05 on the standard deviation of weights of salt packages filled by the new machine? So I'll just go. So you have to say whether the standard deviation of weights is 40 or whether the standard deviation of weights is less than 40. So what it says is now treat. So forget what you are doing till now. Now you are an employee in a company that makes salt packets. Okay. So you know each and every salt packet which costs some 20 or 30 rupees weighs approximately 40. Okay. And it it's not weighing also. It's like some packets will weigh some 45 grams and some will weigh 50, some will weigh 100. If you look at on and whole, if you look at the standard deviation of weights of the salt packages filled by this particular machine is 40 grams. So there is a standard deviation bit. So the difference is 40. Okay, treat it like this. You know the standard deviation, right? The spread is 40. Now a new machine is introduced to reduce the standard deviation. So that means if I wanted to put some 100 grams into a particular packet, so I shouldn't go beyond 140 and I shouldn't go less than 60. So that's my, so I wanted to keep all the packets within one standard deviation. So that's my goal. And what I have done is I have taken some 25 packages which were filled by this new machine. And out of these 25 packets, I have computed the standard deviation, and the standard deviation came out to be 32. Now what you have to do is, at a significance level of 0.05, you have to conclude whether the standard deviation of the weights is 40 or not. If it is, so that means you take it as null and alternative. Okay, so take the null hypothesis as standard deviation sigma is equals to 40, alternative as sigma is less than 40. Now as this is between the variance, test for variance, you have to use chi-square distribution. Also, when if you see that hint given to you, so we have given you the CDF, inverse CDF of chi-square. So that means you have to use chi-square distribution. Okay, I'll give you some 5 minutes. People who know how to do this, please do this.
Sir, could you please recommend some books for NTEM exam?
Books for NTEM exam? No, see, now start reading books is very difficult. What I can recommend you is just go through the graded and practice, okay, for week 11 and 12 especially.
Okay, sir.
Okay, so if you see in the graded assignment only, there will not be any new kind of question. There will be some 3 or 4 hardly variations in the questions. Okay, either we give you alpha like this, significance level we will give you and ask you whether you reject or accept. So that means you have to compute the critical value and compare the critical value with this given value, test statistic, and you have to reject or accept. Or else what we will do is, we will give you the critical value and we will ask you to find the p-value. Okay, so these are the common variations you see in weeks 11 and 12. So what my recommendation is, my strong recommendation is, just stick with practice and graded questions of week 11 and 12 and attend revision sessions.
Okay, sir.
Okay.
Sir, one more query, sir. There are some problems where we are asked to find the sample size, right? Required N. In those questions, for this F inverse values and all, if we vary a small decimal also, like here it is given 13.85, if we use 13.849 or something, a small change in the third or fourth decimal is also giving 1 or 2 numbers change in the sample size. So, and in the practice and graded assignments, I didn't see range being given for sample size. Whenever sample size is asked, it is straight away a number. So, if that is the case, then we are going to face difficulty.
No, that will not be the case in the NTEM. Okay.
Okay. Generally, for sample size, also range will be allowed.
Yeah. We will give the range if it is not coming out to be an integer.
Mostly it will not come to be integer. It will give some 30 point something.
No, yeah. We will give the range.
Okay.
Sir, after quiz 2, I focused more on maths too. If I start tomorrow stats from week 9, am I able to complete this before end up? Okay.
People are doing one night before.
So actually, the in quiz 2 there was a very strong representation of from the mock itself. So will that be a case in NTEM also? Like,
see, mock will resemble 50%. Okay, hopefully 50 to 60%, I can say.
Okay. Sir.
In the NTEM, you might see some two different kind of questions out of all 14 or 15 questions. Okay. Other 13 will be very straightforward. Week 1 to 8 questions will be like if you have done good in quiz 1, quiz 2, that's enough.
So have you shared the weightage of
No. We will
till now?
no.
Okay.
So after 21st revision session, first revision session, we will share the complete weightage for each week. Okay. As of now, roughly I can say more weightages will be for week 9, 10, 11.
Only 9, 10, 11.
9, 10, 11 will have high weightages like 60%,
Okay.
maybe 55 to 60% will be from these 3 weeks.
Okay.
And some 15 to 20%, 15% maybe from the last week. And the other 25% from 1 to 8. Okay. Okay. So let's discuss about this question. So in order to start solving,
Sir, can you have 30 more seconds?
Okay.
Sir, sum of week 11, 12 question, week 12 question is very lengthy, where we have to find the sample variance from the given data. If we use Colab like sir used, but in the exam it's become very lengthy to calculate the sample.
That we know, no?
Sir.
Okay. So if we are giving, then we are being sadistic by making you to compute more and more. We will not be that sadistic.
Okay, sir.
Okay. So even we know that it is time constraint exam. Okay.
Also, sir, the calculator is very.
So don't worry. As I said, see, week 12 is you might see hardly one question from week 12, and that too from section 1 only.
Okay, sir.
Okay. Okay. So let us start discussing about this chi-square distribution. So this chi-square distribution is used in this chi-square test, where this chi-square test is basically to test for variance. So here also we have given you the standard deviation or variance, both are same. So it's like if you square the standard deviation, we are going to get variance. So here in this particular situation, we have two hypotheses. One is null hypothesis, which says our standard deviation is sigma is equal to 40, and the alternative says the weight standard deviation is less than 40. So this less than 40, how we got? So not from the options, from the question, how we can get the alternative hypothesis?
So because from the new machine showed a standard deviation of 32, which is less than 40.
No.
New machine is introduced to reduce the standard deviation.
Right. So if you see words like decrease, low, these things which are lesser, so you understand, right? Decrease, lesser, low, what else? Reduce. Yeah. So if you see these kind of words in the question, so then that means we are trying to reduce our parameter value or decrease. So here we are trying, a new machine is introduced here to decrease the standard deviation. So that means we are testing our standard deviation sigma is equals to 40 with the decreased standard deviation. Decrease means our sigma should be less than 40. When you see words like high, increase, and hike, what else? I'm not getting words.
More than,
greater than, greater. So these if you
Too low.
Huh?
Low.
Low comes in that.
Yeah.
Maximum.
Less than.
No, not less than, greater than.
So maybe one caution here is when it is too low or too high, then it gets reversed.
Then it will be reversed. So
yeah.
So it's like you see the situation, okay? So the other person here, you see the second statement will give you the hint how to pick the alternative. The first statement will give you to pick the null, and the second statement will tell you. So to decrease the standard deviation. So to decrease means initially your null is sigma is equal to 40. So if your sigma is equal to 40 is your null, if I have to decrease that standard deviation, then my sigma should be less than 40. Okay. So read the second statement properly, and from that you will get the alternative. Okay. So this is the alternative and this is the null, and you have to choose whether, so whether you are, so the conclusion is after computing you have to either reject the null or accept the null. If you are accepting the null, then that means you have to choose option A. If you are rejecting the null, then that means you have to choose option B. So that means you are accepting the alternative, which is option B. So how do we do this? So how do we do chi-square distribution? So I'll just go step by step. So for every problem in week 11 and 12, the first step has to be identifying the null hypothesis and the alternative hypothesis. So from the first two statements, you will get the null and the alternative. So the null will be sigma is equal to 40 and the alternative will be sigma less than 40. Once you get this, then the next step is going to be identifying the test statistic. So now, as we are worried about the standard deviations, our test statistic T should be the sample variance. Okay, so there are very few test statistics. Okay, if you are testing for mean, your test statistic should be sample mean. If you are testing for variance, your test statistic will be S square. If you are comparing variances, your test statistic will be the fraction. So Sx square, the sample variance of one distribution divided by the sample variance of the other distribution. So very few test statistics. So if we are comparing two means, then the test statistic will be y bar minus x bar or x bar minus y bar. Okay. So now define, so as we are testing for variance, our test statistics should be E is equals to S square. And as the test statistic is involving sample variance, I know a distribution which will take sample variance as a variable, which is the chi-square distribution. So people who know chi-square distribution, recall chi-square distribution. N minus 1 S square divided by sigma square will follow chi-square N minus 1 with degrees of N minus 1 degrees of freedom. Okay.
So will this information be given in exam?
Yeah, so these things will be given to you. Okay, so all the test will be given to you. So if you are testing for sample mean, what is your test statistic will be given to you. What distribution you have to follow will be given to you. Okay, so we will release that data attachment to you also on the portal. So it will be 5 pages data attachment. So all this tests will be given to you.
It's already on the portal.
It's already there in the portal.
Okay. Then just go, just look at the data attachment. You will get an idea of what to be remembered and what not to be remembered. Mugged up maybe. Okay. So I know that this n minus 1 times S square divided by sigma square will follow chi-square distribution. Chi-square n minus 1. So this n comes from the number of samples I have taken. So from the question you can see that we have taken 25 samples. So n minus 1 will be 24, and sigma is also known to us. So it's not known to us when we compute alpha. So we will be computing the significance level. Okay. So it's not significance level. We will be computing, try to get the C square value. In order to get the C square value, we need alpha, and alpha is given to us as 0.05. So for putting all these things together, we need this sigma square. So the sigma square will be equal to 40 if my null is true. And when I compute alpha, alpha is nothing but probability that I am going to reject the null if given that null is true. And also you see, you don't need to be confused with this test also. So the sign of the test, whether it should be less than or greater than. So whatever the sign is there for the alternative, the same sign will hold for the test. Okay. So that is what we are going to do. So if your S square is less than some C square, you know that that S square is nowhere near to 40. So the alternative will be true. So you will eventually reject the null hypothesis. That is what it is going to happen. If sigma is greater than 40, you expect your S square should be somewhat greater than some C square. And if it is greater, then it is nowhere near to sigma is equals to 40. So you reject null and accept the alternative. So for test, the sign of the test, you don't need to worry. Once you get the alternative, you just use the same sign for your test. Okay, so now you got it. You will reject the null hypothesis if S square is less than C square. So just put, so step 3 will be put alpha is equals to probability of reject H0 given H0 is true. We have given you the alpha and you know when to reject null, and when null is true, your sigma is equal to 40. So now putting all this together, we will get probability that S square. So here it should be probability that S square less than C square is rejecting H0. So in this case, I am going to reject H0. So there should be given this sigma is equal to 40. Okay, H0, if H0 is true, that means sigma is equals to 40. That is equal to 0.05. It is given in the question. So now what I have to do, I know that 24 times S square divided by 40 square follows chi-square distribution, chi-square 24. So I have to multiply 24 divided by 40 square on both sides. So once I do, I am going to get this whole 24 S square divided by 40 square now follows chi-square 24 distribution, chi-square distribution with 24 degrees of freedom. So that will be, that can be written as chi-square 24 less than 24 C square by 40 square is equals to 0.05. Now you see, this is, you take the inverse. So this is F chi-square 24 of 24 C square by 40 square. So if you take F inverse on both sides, you will be getting F inverse of chi-square 24 within the bracket 0.05. So we have given this thing also is given in the question. So just substitute that value, which is 13.8485, and the left hand side will be 24 C square by 40 square. From this you compute C square. So just do 1600 times 13.85 divided by 24. We will be getting 923.33. So C square value is this. And now how do we get this S square test statistic value? From the question, it is given that for that 25 samples, the standard deviation is 32. So the sample variance will be 32 square, which will be 1024. Now you see, when you compare this S square with C square, what we are getting, 1024 is greater than 923.33. Okay. So we will be rejecting S square, we will be rejecting null if S square is less than C square. But instead what we got, our S square is greater than C square. So we cannot reject. the null hypothesis. So if we cannot reject the null hypothesis, that means we are accepting the null hypothesis. So what null hypothesis says, standard deviation is equal to 40. So that is how you have to do. So here we have 3 steps. The first 2 steps will be common for every problem. So for all the problems, step 1 is to identify H0 and HA alternative. And the step 2 will be define your test statistic and identify how to convert that test statistic into the known distribution and define your test. So these 2 steps are common to every problem. And depending upon the problem, if alpha is given to you, then compute the critical value. So here C square is the critical value. Then you can compare the critical value with your test statistic value. And using this test, so here the test is when you compare, your test statistic value should be less than your critical value. Then you can reject your null. So this is the test. So compare this test statistic S square value with your C square value, obtain C square value. If it is less than, so if S square is less than C square, then you reject null. If your S square is greater than C square, just like in this case, we will accept the null. If this is not the case, so we will be giving you some critical value. So we will give you the critical value C square, and we will ask you, we will not give you this alpha, and we will ask you to find the p value. Then what you have to do? So we will not give you the C square also, we will not give you the critical value also. We will just give you this test statistic value, and we will ask you, we will not give you the alpha. Rather, we will ask you, if we want to ask you an NAT question, then we will ask you to find the p value. So in order to find the p value, what you have to do is, the only thing you have to do is, instead of this small c square, you just take 32 square. You just take the test statistic value directly in place of the critical value. Then compute alpha. Compute for alpha, and that alpha will be the p value. So p value is nothing but the least significance level at which you will reject the null. That's it. So it is also a significance level. It is also a significance level. But if I use, in place of critical value, if I use the test statistic value, then the corresponding significance level will be equal to the p value. Okay, these are the 2 variations we will be having. So this is one variation where alpha is given, and you have to compare between the test statistic and the critical value. Okay, we will do one more problem like this. Maybe the tests will be different, that's it. So now a sociologist focusing on popular culture and media believes that the average number of hours per week spent on social media is different for men and women. Okay, so this is just the context. Okay, so here the context is, a sociologist is doing some research on the average number of hours per week spent on social media, and he is claiming that it is different for men and women. So here we have 2 different samples now. One is for men and one is for women. Now what the researcher did, the researcher knows that the standard deviations of amount of time spent on social media are 8 hours per week and 10 hours per week for men and women respectively. So the standard deviations are given to you. That means the population variances are given to you. Population variances are 8 square and 10 square. Now examining 2 independent random samples of 100 individuals each, if the average number of hours spent on social media for the sample of men is 3 hours greater than for the sample of women. So it's like average. Okay, here we are looking at the difference between the sample mean of the men and the sample mean of the women. It is seen that the difference is greater than 3. Okay, 3 hours greater than the women, so the difference is 3. What conclusion can be made from a hypothesis test where here alternative and null is given to you, and alpha is also given to us. What we have to do is we have to find the critical value and compare the critical value with this 3. Okay, and here if you see, the alternative is not equal to, so it is not left tailed or right tailed, it is two tailed. Okay, so this is comparing between two means. So you can, by looking at the null itself, you can identify. So if it is between comparing two means, your main goal is, your step 1 is solved. Step 2 is identify the test statistic, identify the distribution that involves this test statistic, and define the test, and using alpha compute find the critical value and compare that critical value.
Sir, standard deviations are samples.
Standard deviations are for population.
Sir, till only 7 this class will last, right? Or 8?
8, right?
8,
But I
okay.
will try to end it before only. 8 o'clock you have session, right? No?
What session? So no sessions. 8 o'clock, no session, sir.
No session. Max 2, there is no Max 2 session.
But in my calendar is not showing, sir.
Okay.
Nor mine.
Okay, did they push the deadline of week 12?
No,
Do you
Max
have week 12?
11 only. Tomorrow is the
Okay,
deadline.
okay. So
Yeah,
you
it's
don't.
week 12 deadline.
Already 1 week pushed.
Okay, you don't have week 12 in Max 2, right? Max 2 and Max 1.
No, sir.
Yeah, okay.
I think today is deadline of stats.
No, tomorrow only.
These events.
So the two-tailed test is a slightly complicated test because the mod will come into the picture. Okay, be careful about that modulus.
Sir, why is FZ inverse bracket 0.025 not given value?
0.025
0.025
is given, right?
Yes.
The alpha is different.
See, that is what I said. See, this is not one-tailed test. This is two-tailed test. Our rejection region will be on both sides.
Yes.
Okay. So that will be divided into half. So if your alpha is 0.01, so the right side rejection region should be 0.005, and the left side also you should have some probability, rejection region probability 0.005. So you will be using either one of it. Okay. So you will get to know why we use 0.005. Okay, did anyone know how to solve this?
Yes, sir, give some time.
Yes, sir, we are doing.
Okay, do. Then do.
Sir, in this time, can you please tell how this stats 2 will help in upcoming diploma courses?
See, stats 2, see what you will do in machine learning foundations, or maybe if you are a data scientist, what are you going to do?
Summarize data.
So you will be given some large spreadsheets of data, and you have to, from that data, you have to analyze the data and put it in a document form so that everyone will be able to easily understand. Right?
Yeah, so making their way
So,
easy. Yeah, making easy to understand what's going on.
making easy to understand by anyone. So that is what. See, you have to analyze the data basically, right? So how do you analyze the data? From a given rows of some 10,000 rows and some 20-30 columns of data you have, what will you do? You will definitely have to use some model. Either you convert all them into a graph, or you just model something and fit that particular data into some distribution, and then you see the averages or whatever you want to show. So that means you will put your data into some model, and that model is provided by mathematics and statistics. So most of the data scientists are going to use statistical models. Okay. And without knowing these models, what will you do is, if you don't know these models, what will you do is you will see the data and you will present the data as it is, and no one will understand. Okay. So yeah, as of now, the straight connection will be to machine learning foundations. Okay. So we will be revisiting this hypothesis testing and parameter estimations, distributions again in machine learning foundations. Okay. Okay. What about the number of submissions in question 2? 5 people submitted. Okay, shall we go and discuss?
Sir, 1 minute.
Yes. 1 minute. Huh? Okay. Good that you people. So how many of you watched the last term's live sessions? Week 11, 12. Has anyone gone through the live sessions?
Not entirely, but we just skipped and viewed some contents where I had doubts.
You told 3 sessions are there. So one session fully I went through.
Okay.
Second session started, but by the time Python
OPP came.
He was there, so we did not proceed further.
So people who got some time, you can go through week 12 sessions also. I hope week 12 I hadn't got chance for the last 2 terms. Maybe next time I will take an open session of week 12. Week 12 has pretty much to discuss. Each and every test has some very well defined steps to be solved, and it will be good. And understanding it with graphs will make the things much more easier.
In that first session also, there are in the first almost half an hour to 45 minutes we were discussing, only on that what do you call
acceptance
activity question 1, sir. Whether it is I couldn't remember. Almost 45 minutes.
Yeah. We wasted some time there.
Yes, sir. That session even I have went through that question.
Maybe the first 40 minutes you should skip, I guess.
But ultimately, what happens, sir? What is correct? What is wrong?
No, the answer which is given is correct.
As given only. Yeah. Later I would understand that.
Okay.
Is it done?
So 1 minute is done. So again, this also, the step 1, step 2 will follow the same thing. The key thing is, okay, step 2 also we will be giving to you. Okay, in the data attachment you can see we will be giving you that test statistic test and
x bar minus y bar normal.
Everything will
0,
be
sigma square, sigma 1 square by n1 plus sigma square 2 by n2.
We have two
right.
sample z-test.
Yeah, this is two sample
With
t-test.
with that formula sheet being given, there is nothing much to do from our end.
But the thing is, you have to identify.
After identifying the null and alternate hypothesis.
Alternative hypothesis and which test you should use, that clarity you should have. That's it. And that is what we need also. So given the situation to you, which test will you be using? So in future also, once you become a data scientist, once you know what test to be used, you have the resources to use, right? So once you know, so this is a concept which is coming. So if I use the t-test, I will get the result. Then you can go online or somewhere, you search what is t-test and put all your data there, and it will give you the results. So we only expect you, by reading the statements and all the situation context, whether you are able to identify what test you have to do in order to get the conclusion. That is what we expect from you. Maybe some computation part. If we expect some computation part, we will ask you the p-value. That's it. Other than p-value, we can't ask you anything in week 11 and 12. Okay, so let us see again. So it is given, let us say, as we haven't given you any random variables, so let us fix some random variables. Xi's and yi's represent the average number of hours spent on social media by men and women respectively. So now I have two samples with me. X1 to X100 follows a normal mu1 comma 8 square. This 8 square came from the question only. In the question it is given. And again y1 to y100, these are 100 women samples. Their average number of hours per week they spent on social media. And this follows normal mu2 comma 10 square. And mu1, mu2 we don't know. So we are testing for that mu1, mu2 only. And what we know, the sample means of this 100 men and 100 women, the difference between the sample mean is equal to 3. Okay, so this is what we know. From here we will define the test statistic. So test statistic, we know that while we are comparing two sample means, our test statistic should be x bar minus y bar. And why this x bar minus y bar is because it has a very good distribution. It follows a very good distribution, which is normal mu1 minus mu2 comma some sigma 1 square by n1 plus sigma 2 square by n2. Okay, this is the distribution. This x bar minus y bar follow. So this you can get it right. Many from week 7. So this is just the x bar. X bar is actually coming from sum of normals. Sum of normals is a normal distribution. Again, y bar is also a sum of normals. That will also follow a normal distribution. Again, it is combination between normal and normal. So minus is also nothing but, so you can write it as x bar plus minus y bar. So minus y bar, treat it as a new random variable. So again, it is a sum of two normals. Again, it will follow normal. By using expectation and some variances of sum of independent random variables, you can get the expectation value will be mu1 minus mu2, and the variance value will be sigma 1 square by n1 plus sigma 2 square by n2. So you can get it easily.
Sir, in this two sample test, the alternate is always not equal to. Even though specifically the test statistics is given that the sample men is more than women.
No, then it will change, right? But we haven't seen any such kind of problem as of now, right?
Here in this question, the data is given like that, right? The men sample data of men is more than women by 3.
It is given here, but also it is given that your alternative I have taken is this.
It is given, but is there a chance that it may be not given and we have to take greater than or something like that? Alternate?
We haven't dealt such kind of problems till now. Okay.
Okay. Right.
So that is why, in order to remove this confusion, that is why we gave null and alternative in the question itself.
Yes, sir. But to reject the null hypothesis, we have to take the greater only, no? Like, for example, the test here.
See, here we are including mod because we don't want y bar minus x bar or x bar minus y bar. So the difference itself, if it is greater than some c, then I can conclude that the sample means are not equal. I can say I will accept the null. So it is very likely to understand, right? I am trying to compare mu1 and mu2. So null says mu1 is equal to mu2. So if I see the difference between them, mu1 and mu2, if the difference is greater than some value, then I am pretty much sure that mu1 and mu2 are not equal. So I will reject my null. I will reject my null if the difference is greater than something. And why we took mod is because that greater than, see, if I have to take x bar minus y bar or y bar minus x bar, which one I have to take? Which difference I have to look at? If my x bar minus mu bar is greater than c, also mu1 will not be equal to mu2. Same way, if my y bar minus x bar is greater than some value also, then also mu1 is not equal to mu2. I can strongly say that. So that is why modulus of this difference is greater than some c, then I can pretty much sure that these two are not equal. Okay, that is why we take modulus and we look for greater than c here. Okay. Okay. No.
Okay.
So we are comparing sample means. Okay. If the difference is pretty much close to some small value, then we're very likely to say that okay, maybe the sample means are equal. If the difference is greater than some 10 or 20, then we can easily say that the difference itself is 10 or 20. How can we claim that? How can we say that mu1 is equal to mu2? So we will reject h0 if the difference is greater than some c. So that is, once you get all these things, now put it in alpha. Alpha is equals to probability that you reject h0 given h0 is true. When h0 is true means mu1 is equal to mu2. If mu1 is equal to mu2, this test statistic will follow normal 0 comma 164. 0 comma 164 by 100. So direct. So now you see the alpha will be equal to probability that you reject h0. When you are going to reject h0, when mod t is greater than c, given h0 is true. So when h0 is true, I know this t will follow normal 0 164 by 100. So if it is following normal 0 comma 164 by 100, then what I have to do, I have to, in order to convert into standard normal, I have to subtract expected value of t divided by square root of variance of t. Expected value of t is 0, square root of variance will be 164 by 100, and I will do it on both sides. Then it will be like mod z greater than c by root over 164 by 100. So c minus 0, so t minus 0 will be t only. So c minus 0 will also be c only. So now understand how this probability that mod z greater than c by square root 164 by 100 can be written as 2 times fz of minus c by square root 164 by 100. If you can able to get this, then the other parts are very easy. How many of you got this?
So both sides adding, right? So 2 times. Similar distribution. Symmetric distribution.
Right. How many of you got this? Hand raises.
The symmetry part?
Like how this probability that mod z greater than c by root over 164 by 100 can be equal to 2 times of fz of minus c by square root 164 by 100. Only 5, 6, 7. Okay. Okay, maybe quickly for others, I will give you some idea. So why did I stop my share? So quick idea is probability. How can you write this mod z is greater than some c? When will be your mod z will be greater than some c? So just remove modulus from the picture. What will you get? So either your z should be greater than c or your z should be less than minus c. So there will be two cases, and split them into two cases and try to convert one to the other side. Okay, so if there is time, I will do this at the end, but I recommend you to do this. Okay, so remove the modulus symbol first of all. So mod z greater than c by root over 164 by 100. This is one event. Treat this as one event. Split this one event into two individual events by removing one. One event will be z greater than c by root over 164 by 100, and the other one will be z less than minus c by root over 164 by 100. Okay, there will be two different probabilities. So you have to add those probabilities, and from there you will get. So by converting one from the other, one to the other, you will get. How minus?
And how do we compute p-value for this?
So instead of c, you take 3 in place of c.
Okay. So it will be probability of mod of x bar minus y bar greater than 3. I tried doing that, but it is giving some weird answers. Okay, I'll check again.
Yeah, check again. How minus is? See, when mod x greater than c, if I have to split, if I have to remove the mod, how I can remove mod? When will mod x be greater than c? Either my x should be greater than c, or my x should be less than minus c. If my x is less than minus c, the modulus will make it greater than c. Okay, so for example, when will mod x be greater than some 10? If my x is greater than 10, then directly mod x will be greater than 10. That is okay to understand. And the other case is when x is less than minus 10, like minus 11 or minus 12 or minus 13. Then in that case is also when I take mod, the minus will go off and it will be greater than c. You got it? These are the two possible cases while you remove mod. And from that you will get.
In place of mod, we can write plus or minus z.
Plus or minus z, and you can do. So once if you are convinced that alpha will be equal to 2 times of fz of minus c by root over 164 by 100. Now from there you see you take this 2 to the left hand side and take this fz also to the left hand side, that will be inverse, and then this root the denominator part to the left hand side and the minus also to the left hand side, and everything in the left hand side bring it to the right hand side, and whatever left in the right hand side, which is c, to the left hand side. Then our c will be equal to minus root over 164 by 100 fz inverse of alpha by 2, and this will be like minus root over 164 by 100 fz inverse of Alpha is given to be 0.01. Now alpha by 2 will be 0.005. Okay. So this is why we have given the value of fz inverse of 0.005. Okay, use that. So that is minus 2.57, and if I substitute, I am going to get C value to be 3.29. And now I got the critical value as 3.29, and I have my test statistic value, which is from the problem. It is given as 3. Now compare these two. So 3 will be less than 3.29. If I compare 3 and 3.29, I know that 3 is less than 3.29. So what happened? Our test statistic mod t is less than C. We got mod t less than C. But when are we going to reject null? When mod t is greater than C. So that means we cannot reject null, we will accept null. Okay. So always, if alpha is given, it's the comparison between the test statistic value which is given in the question and the critical value which you are going to compute by using alpha. From the test, look at the test. So test says reject H naught if your test statistic is greater than the critical value. Or in other words, you accept the null if your test statistic value is less than the critical value. So we got the critical value, which is 3.29. We also have the test statistic value, which is 3. So from there we can see 3 is less than 3.29. So therefore we will accept the null. That's it. Okay.
Sir, so in the previous question, if we have to find power, what alternate hypothesis should we take?
Then it will be difficult, right? Which one will you pick? See here, if mu1 is not equal to mu2, then mu1 minus mu2 is the parameter involved in this test statistic. Okay. So maybe we should give you the null is mu1 minus mu2 is equal to 0, and alternative is mu1 minus mu2 is equal to some 2 or 3. If we had given like that, then while you compute the power, instead of 0 you have to use 2 or 3 here. Then your calculations will be like minus 3. There will be in the numerator, there will be minus 3 on both sides. Okay. So it will involve that expectation also, mu1 minus mu2 also into the picture. Okay.
Thank you, sir.
So we have seen chi-square test. We have seen 2 sample Z test. Now this is t-test. Where, so if you read the question carefully, we will be giving you the sample variance instead of population variance. So let's go to and discuss about this question. The manufacturer of a new car claims that a typical car gets a mileage of 36 kilometers per liter. We think that the mileage is less. Okay, see here, we think that the mileage is less. So the mileage which the manufacturer claims, we think that is less. To test, we think that the mileage is less. To test our suspicion, we perform the hypothesis test with H naught mu is equal to 36 and HA mu less than 36. So it's not 36. We think that the mileage is less than 36. We should have been more precise. So see, this word less also gives you some indication about alternative. So mu is less than 36. Suppose we take a random sample of 100 new cars and find that their average mileage is 36.4 kilometers per liter and the sample standard deviation is 4. So now you see, we haven't given you the population standard deviation, and instead of that we have given you the sample standard deviation. And what does a t-test say about a null hypothesis with a significance level of 0.05? Okay. So what you have to do is bring whatever you know in week 11, whatever you have done in week 11, bring that here, and instead of population variance, you just put sample variance. Okay, in place of sigma, you have to use S. And whatever we did in the question 1 and question 2, you have to follow the same approach and use hint also. And tell me whether you are going to reject null or accept.
Sir, here the sample data is more than the null. Hello.
Sorry, Mohan Raj, you are speaking something?
Yeah, here the sample data is more than the null, and we are testing for less than the null. So that itself gives the answer, right?
Is it giving the answer?
I think so, because the sample data average is more than the null, and we want to test whether it is less than the null. Then we don't need to make any calculation, right?
Looks like so.
No, but it doesn't work that way, sir. In the previous question, when the null hypothesis was both the means are equal, but actually the observed was men's, average was 3 greater than women's, but we ended up accepting the hypothesis that both are equal, right? This being greater
Both
than means
equal.
how significant, how significantly greater, whether this 0.4 being great is significant or not to accept. That's what we are looking at.
But that is two-edged, no? This is only one-sided.
So whatever may be the case, no? I'm just saying for an example.
Only at one side. You will never reject on the other side.
See, even I partially agree with Mohan Raj. Sometimes even I do the same kind of not even calculation. From the intuition itself, it is quite evident. Yeah. I don't know why it is given 36.4. Yeah. So the reason will be, see, the critical value which is going to come will be obviously less than 36.
Correct.
I think it was meant to be 30.
Then it should have been 35.4 or something.
Yeah.
It will be less than 36 at this significance because it is minus 1.66, right? 36 minus something it will always be.
Also, see, if it is left tail test, your critical value will be left side of mean, left side of what you are trying to test. So
sir, and we increase this, we change this significance level so that if this F inverse becomes positive, then we end up getting a critical value that is more than 36, right?
No, it is always left side, no? It is left side, that means always it will be less.
No,
So what is the C here? Critical value?
No, I am just saying if we change this 0.05 to some other value so that the F inverse becomes positive plus 1 point, suppose.
Whatever significance value you put, it will be always be negative.
No. See, then alpha should be, what should be alpha? Greater than 0.5.
Okay.
Greater than 0.5 alpha is very bad test, right?
Yeah.
Even if alpha is greater than 0.5, it will be minus only.
No, right? Is it?
Yes.
What if your alpha is 1?
Alpha is 1.
You are going to reject whatever it is, you are going to reject null.
Yeah.
Right?
Yes.
So like this, what do we mean by alpha is 0.5? It slowly comes out that if the test statistic value falls,
if the alpha is 0.5, then this value is becoming 6.6 something. This F inverse value. It is a positive value. So, like if we change the significance level, of course, if it is a bad test, then the values change according to significance level, right?
Yeah. But see, the thing is, usually, most of the cases are not even the good test will always be like your significance level or the rejection region will always be, if I am looking for the left side, will always be very much far from the mean, which is 36. It will be very far to the left hand side. Okay. And critical value will turn out to be less than 36. So then only we will test, right?
Yeah.
Why to test if the average is somewhere greater than 36 and you are you are comparing with the alternative which is mu less than 36.
Yes.
This is not a good way of comparing. I don't know why they gave, but Mohan Rao, that's a good observation is what I think.
Yeah.
Okay, so let's see. The same approach we will follow. Here it is given to us that null and alternative is given to us, and once alternative is given to us, we can also write down the test. We are going to reject H0 if my X bar or the test statistic is less than some critical value C. Okay, and X bar is given to be 36.8, 36.4. Okay, that is 36.4. Now the test statistic is X bar, and I am going to compute my critical value. In order to compute my critical value, so we do not know the population variance. Okay, so sigma square is unknown, but we know the sample variance, which is given to be 4 square. Is it 4 square? Yeah. So sample standard deviation is given to us, which is equal to 4. The sample variance I can compute, it is 4 square. So what I will do is I will follow the same approach. So I will just try to standardize this X bar by subtracting expected value of X bar divided by square root of variance divided by n, where this variance is not the population variance. This variance is the sample variance now. So X bar minus 36 divided by root over S square by n less than C minus 36 by root over S square by n. So this X bar minus 36 divided by S square, we know the sample variance is 16 divided by n. We also know that it is 100 new cars has been tested. So it is 100. So from there, see this X bar minus 36 by root over S square by n. Now this follows a T distribution with n minus 1 degrees of freedom. So this is FT99, C minus 36 by root over 16 by 100. And alpha is given to be 0.05. And 0.05 is equals to t99 of c minus 36 by root over 16 by 100. Now if I take the inverse and take the denominator to the left hand side and minus 36 also to the left hand side and all the left hand side to the right hand side, I'll get c is equals to 36 plus some root over 16 by 100 times f inverse of t99 of 0.05, and this is given in the question, it is minus something, so it is a negative value, so we will definitely get 36 minus something, which is 35.336. So we got the critical value as 35.336 and the sample mean value is 36.4, and we can observe if we compare this test statistic with this critical value, 36.4 is greater than 35.336. So we will be accepting the null. So we will reject null only if x bar is less than some c. So we will accept the null. And most of the times here, this f inverse of t99, the alphas, usual alphas we take is 0.01 and 0.05. And these are the common alphas we use. So for this common alphas, this f inverse of t99 or any t, it will be negative value. So whatever the critical value you compute, it will be less than 36 only. Simply you can, from that intuition also, you can directly answer this particular question. Okay. So in the last question I have the F distribution. So this is the last distribution, last test we do, and this test is between comparing two variances. So an IITM instructor conducts 2 live sessions for 2 different classes, quality A and B in statistics. Session A has had 25 students attending while session B had 50 students. The instructor conducted a test for the 2 sessions, although there was no significant difference in mean grades. Session A had a standard deviation of 12, while session B had a standard deviation of 15. So we have given you the standard deviation, sample standard deviations, 12 and 15. Can we conclude at the 0.05 level of significance that the variability in marks of class B is greater than that of A? Okay, so you have to say yes or no. So here, identifying null and alternative is very important, and the test statistic is also, identifying test statistic is also very important. So what will be your null?
Sample variance are equal.
Variances are equal or standard deviations are equal. And alternative?
Variance of class B is greater than class A.
Class B is greater than class A? No.
If we take A as 1 and B as 2, we can write sigma 1 equal to sigma 2 and sigma 1 less than sigma 2.
Sigma 1 less than sigma 2? Are we, see, we just want, can we conclude the variability in mark of class B is greater than that of class A?
So it is only one
Yeah,
sided.
if we take A as 1 and B as 2.
This is one-sided test, right?
Yeah, one-sided.
Yeah. Since variability is and standard deviation are obviously positive entities, we can say that variability is greater means standard deviation is greater.
So you can also, seeing the hint, you can also identify which side of CL you should, whether you have to take the left critical value or the right critical value.
So it is right.
Here it turns out that you have to take the right critical value.
So a few minutes before you were saying right critical value and left critical value, but this is not a two-tailed test, right?
No, it's not
We
a
have only
two-tailed
one
test.
C.
But the distribution will have two values, right? We have to take the right side.
See, that is why we have given you 0.95, right? It's not 0.975.
Yeah, it was just 1 plus C. When you said right critical, left critical, I confused it with
No,
CR and CL.
No, not that.
And I thought it is. Yeah. This I got it.
See, if it had been two-tailed test, what would have happened? Either we will give you F inverse of 0.025, or maybe we will give you 0.975.
0.975. Yeah.
So people who hadn't watched any week 12 lectures, please be quick. Submit the assignment quickly. Watch week 12 contents. And be ready by 21st. Okay, we will be revising week 9, 10 on 21st. And on 23rd is it? Let me go back to the calendar and yeah, and on 23rd we will be revising week 11 and 12, and on 26th we will be having this mock discussion for intern. And most probably we will release mock by Friday night or maybe Saturday morning, early morning. So you hardly have some 2-3 days to spend some more time in these 3 days and complete week 12 as soon as possible. Okay, what happened here? Done? Yeah, I have seen 6 responses and now I am seeing only 5 responses. Done?
So.
Okay. So if we treat sigma 1 and sigma 1 as the standard deviation of A and sigma 2 as standard deviation of B, our null will be sigma 1 is equal to sigma 2 and the alternative will be marks of section B is greater than section A. So the null is sigma 1 less than sigma 2. So what I am going to do, I am going to reject my null if the ratio of the sample variances is greater than some 1 plus CR. So if this S square B by S square A is greater than some 1.5 or 1.6, then I can surely say that the variance in this classroom B is higher or greater than the variances in classroom A. So like that you have to think. So now the people who know F distribution, so this ratio will follow F n2 minus 1 comma n1 minus 1, where n1 and n2 are given to us. Again, these n2 and n1 are the degrees of freedom. So if I substitute n1 and n2, I will be getting S square B by S square A follows F49 comma 24. So now test statistic, I have this test statistic is equals to S square B by S square A. So now alpha will be, I am going to probability that reject H0 given H0 is true. So that means alpha will be equal to probability that when am I going to reject H0? When T is greater than some 1 plus CR, given that sigma 1 is equals to sigma 2. So now when sigma 1 is equals to sigma 2, so I know how to write this F distribution of F49 comma 24. So that can be written as alpha is equals to 1 plus probability that T less than 1 plus CR. Now this probability that T less than 1 plus CR, I can write it as F49 comma 24 within the brackets 1 plus CR, and this one, so this, now I take everything to one side except CR on the other side, or maybe 1 plus CR on the other side. So it will be like 1 minus alpha and take the F inverse, then we are going to get 1 plus CR will be equal to F inverse of F49 comma 24 of 1 minus alpha. So alpha is given as 0.05. So 1 minus alpha will be 0.95, and this value is given to us as 1.86. Now you can see the ratio between the sample variances, the critical value we got it as 1.86. So the ratio shouldn't be greater than 1.86. But if you compute the ratios given in the question, the sample variances are given to us 15 square by 12 square. It is coming out to be 1.5625. And the ratio, the test statistic value is coming out to be 1.56. And the critical value which we got is 1.86. So the test statistic is less than the critical value. So therefore, we will accept the null. Okay. So what
variance are equal, so then.
What this implies is at the level of the significance level of 0.05, the variability of marks of class B and the variability in the marks of class A, we can't say that one is greater than the other. We can't say they are, it's not greater than, we are concluding that they are equal. Okay.
Sir, sir, if we take SA square by SB square, then we need, it will be left limit, sir.
It will be, then you have to take the other way around, right?
Okay.
So you don't want your, depending upon the hint given to you, you have to use which side. If
then we will need F25 gamma 49 for 24
then
gamma
you need F24 gamma 49 of F inverse of 0.05 we need.
Okay. Sir, so depending upon B square by SA square is greater than 1, sir. So from there also we can guess, sir. It will be right side.
So that is what we are expecting in the alternative. So look at what alternative is expecting. Okay. So it's like you should be like, how good I can reject null. How efficiently I will be able to reject null. So that is what we strive for. We will try mostly to reject null, but in most of the cases what happens is we are unable to reject null. So that is what it will happen. Okay.
Sir, our null hypothesis mostly contains an equal sign, right? But in the general case, like outside the application, it will have inequalities also, right?
Usually, see, whatever we learn in statistics, okay, not only in this statistics course, usually when we study statistics, in order to understand these computations better, we will treat null hypothesis to be simple. Then only it is you can easily compute this alpha, beta, and you can easily observe when we vary alpha, what happens.
But in this case, just because their variance of A is not less than B, it can be other way, right? It is not good enough to say they are equal, right? Just because it is not greater, we cannot say it's equal, right? It can be less than also.
That's what my question is. But see, what happens here is we cannot reject null. So that is what you can say in this particular case. So you cannot say that it is greater than.
We are accepting null, sir.
Yeah, we are accepting null, or you are unable to reject null. So treat it in this way. We are unable to reject null. Okay. So if you are unable to reject null, we cannot conclude anything directly saying that this is greater or that is lesser. Okay.
Sir, so in the same question, if we take SA square by SB square, so we'll take left limit 1 minus CL.
We'll take left limit. Yeah, correct. But the corresponding values also should be given to you. So that is what I meant. Okay. So if we hadn't given you the left F distribution values, it is very difficult to compute.
Sir, no, all the questions, if the distribution, we should take it as normal, sir.
No, right? Where did we took it as normal? See, this F distribution is not normal. That is why we have
Not
different
X,
critical.
That X distribution and Y, that random variables.
No, random variables. I didn't understand what you are trying to ask. Can you repeat?
So, for example, if X is the mileage, then we should take it, treat it as normal.
Oh, see, it's not normal. So the distribution the distribution mean and variance will be given to you. We never say that it is normal.
Okay.
But for testing, this expectation and variance is sufficient because of we have CLT. Okay, everything from any distribution it comes, we can actually put it into normal. So that is why we don't worry too much about what distribution it is coming from. Rather, we just need only the sample mean and the variance. Okay.
Sir, but in the Z test, that X bar is becoming normal.
For Z test, it becomes.
Sir, it is normal because the individual samples are also normal, sir.
No, man. See, you don't need that. Whether it is normal or not normal, we don't worry about that. From which distribution it is coming, it's unnecessary for our calculation.
So we are taking only this sample mean as normal in Z test.
Sample mean as normal. Where did we take sample mean as normal?
In the Z test, sir, we reject if X bar is greater than C.
Even there also, sample mean may not be normal, right? We just do sample mean minus expectation of sample mean divided by square root of variance of sample mean. Then that will convert to standard normal.
Okay, it is like using CLT.
Okay. Using CLT.
Okay, sir.
Okay.
Thank you.
Okay.